Today I will discuss Mann-Whitney U statistic. So I start with U statistics. What is U statistics? Gamma theta, a real valued population characteristic f x1 x2 xm is an unbiased estimator estimate of gamma theta if m is the minimum sample size for which an unbiased estimator of gamma theta exists, then f x1 x2 xm is called a kernel. Corresponding to a kernel there always exists a symmetric kernel namely fs x1 x2 xm one by m factorial sum over sum over all possible permutations of the suffixes f xi1, xi2, xim, where the summation is over m factorial permutation of the suffixes Now we define U statistics as follow. Let f x1, x2, xn be any unbiased estimator or estimate, since we use small x1, small x2, small xn. So this is the realization of capital Xi. So this is a estimate. Let fx1, x2, xn be any unbiased estimate of the estimable parameter gamma theta, then the value of the U statistic corresponding to fx1, x2, xn xn for a sample of size small n where n greater than m is defined as U x1, x2, xn 1 by NCM, n choose n, sum over all possible combination of m integer from n integer, f is xi1, xi2, xim. Where sum over C, capital C, is over all the NCM combinations of small m integers from n integers and f suffix s is the symmetric kernel corresponding to f x1 xm. Example, for the class of absolutely continuous distribution, the U statistic statistics corresponding to estimable parameters mu and sigma square are given below. We know expectation x is equal to mu. Then the corresponding U statistic for the sample size small n is 1 by small n, I from 1 to small n, small xi, this is equal to small x bar. So this is based on sample size small a. See here m equal to 1 and if s x I is small xi, so using 2 we get u equal to 1 by nc1 sum over all possible combination, means since we take 1 from 1 observations from small n observations, so it should be I from 1 to small n small xi equal to x bar. Now we know sigma square equal to expectation x square minus e square x. Again, since xi's are IID, independent identically distributed random variables, so we write it as this equal to expectation x1 into x2, since xi's are identical, so expectation xi x1 equal to expectation x2. Now since xi's are independent, so again we write this portion is expectation x1 into x2, and this is equal to this. So this is a kernel. So this is a kernel based on x1, x2. So we denote this fx1, fx2 because this is the minimum number of sample, that is 2, for which fx1, fx2 is an unbiased estimator of sigma square. So this is a kernel, and the symmetric kernel is if s x1 x2 taking all possible permutations, that means x1 square x1 x2 plus x2 square x1 x2. That means this is a 1 2 and this is 2 1 divided by 2 factorial means 2. So this is equal to x1 minus x2 whole square by 2. This is symmetrical. Then U statistics is based on n sample. Here m equal to 2, so NC2 1 by NC2 sum over all possible combination, then we write it I1 less than I2 if S xi1 xi2, so it is equal to NC2 sum over I1 less than I2, and this is equal to this should be I1 I2, this portion, so I1 xi1 minus xi2 whole square by 2, and now this is equal to n into n minus 1 sum over I1 less than I2 xi1 minus xi2 whole square equal to 2 into n minus 1 sum over I1 not equal to I2 xi1 minus xi2 whole square equal to, since this is again equal to sum over I1 equal to 1 to n sum over I2 equal to 1 to n xi1 minus xi2 whole square, and this is equal to 2 into n minus 1, and we write it like that, this portion, if you write this portion xi1 minus x bar plus x bar minus xi2, then this is equal to n into I1 1 to small n xi1 minus x bar whole square plus n into I2 minus 1 n xi2 minus x bar whole square. So this is equal to this is equal to 1 by n into n minus 1, this is equal to n into n minus 1 s square, again this is equal to n into n minus 1 s square, so this is 2 into n minus 1 s square. So this is equal to s square. That is a sample variance. This is nothing but a sample variance. Now we discuss Mann-Whitney U test. Mann-Whitney U test, which is based on U statistics. This is lecture 5. This is one of the most widely used two-sample non-parametric test and is a useful alternative to the t-test when we do not make the t-test assumptions. So this is a this is one of the most widely used two-sample non-parametric test and is useful alternative to the t-test when we do not make the t-test assumptions. The Mann-Whitney U statistics defined as the number of times y precedes in capital X in the combined sample of size capital N equal to m plus n. Here I want to mention that suppose x1 xm be a random sample drawn from a continuous populations with CDF fx small x and y1 yn be another random sample drawn from continuous population with CDF fy small y. And here we want to test h naught fx small x equal to fy small x for all x. So now come to the point. So U statistics is the number of times y precedes in x in the combined sample of size n equal to m plus n. Assuming continuity of the distributions fx and fy, we define a indicator variables dij equal to 1 if yj less than xi and equal to 0 if yj greater than xi. So this is a main indicator random variable. Then U statistics equal to, this is a Mann-Whitney U statistic, sum over I from 1 to m, j from 1 to small n dij. Similarly, we define u dash, which is equal to number of xi yj pairs for which xi less than yj. So this is nothing but a sum over I from 1 to m, j from 1 to n, 1 minus dij. So therefore this is equal to mn minus u. This implies u plus u dash equal to mn. When our alternative ha fy x less than equal to fx x with strict inequality, for some x. Now this is true when maximum number of yi less than xj. That means this value of u should be large and automatically value of u dash should be small. So large values of u would reject h naught fyx equal to fxx for all x in favor of ha. That means this, or small value of u dash would reject h naught in favor of ha. Now let theta 2 is a median of y and theta 1 equal to median of x and theta equal to theta 2 minus theta 1, and suppose our null hypothesis theta equal to 0 versus alternative hypothesis theta greater than 0. So H1 is true if u will tend to or it is better to say u dash will tend to be larger than u. Why? See, this means median of y is greater than median of x. So more than 50% of y values greater than more than of 50% of x values. So this means maximum number of yj greater than xi, and this implies the value of u dash is greater than u. So if h1 is true, this implies u dash will tend to larger than u. Similarly, when h naught theta equal to 0 versus h2 theta less than 0, this implies h2 is true if u dash, it is better to say u will tend to be larger than u dash. And for both tail test, H3 is true if minimum of u dash is small. So we conclude that the selection of u dash and minimum u dash depends on the type of alternative. If the computed value of the appropriate u is less than or equal to the tabulated value, then we reject the null hypothesis at the stated level of significance. The Mn dij's are Bernoulli random variables with probability Dij equal to 1, that means probability y less than x. So this is nothing but a minus infinity to plus infinity fyx dfx, let it is pi, say, and these dij are not mutually independent. For common scripts, common subscripts, let probability yj less than, I explain this, less than xi and yk less than xi, then this is equal to minus infinity to plus infinity fyx whole square dfx equal to pi 1, say, and probability yj less than xi and yj less than xk minus infinity to plus infinity 1 minus f x y whole square dfy y equal to pi 2, and we see that this pi 1 is not equal to pi square, and similarly that this is not equal to pi 2 is not equal to probability yj less than xi into probability yj less than xk, that means pi square. So we conclude that dij's are not mutually independent for common subscripts. Now covariance of dij dik equal to pi 1 minus pi square for j not equal to k. Covariance dij dkj equal to pi 2 minus pi square for I not equal to k. Covariance dij dhk 0 for I not equal to h, j not equal to k is checked. Then this implies expectation of u, this is equal to mn pi, and variance of u equal to mn pi minus pi square capital N minus 1 plus n minus 1 pi 1 plus n minus 1 pi 2. This, you also check this. This is your homework. Then you also check, this is again another homework, u by mn is a consistent estimator of pi. We know expectation of t tending to theta and variance of t tending to 0 as n tending to infinity, then t is a consistent estimator of theta. Use this result, you check this, u by mn is a consistent estimator of pi. This is your another homework. And the Mann-Whitney U test, hence the Mann-Whitney U test is a consistent for alternative H, H1, H2, H3 and H. H means fyx less than equal to fx with strict inequality for some x, and in terms of pi, the null hypothesis is pi equal to half, and alternative hypothesis pi greater than half, pi less than half, pi not equal to half. This is theta greater than 0, this is theta less than 0, and this is theta not equal to 0. And under H naught, u minus mn by 2 by root over mn n plus 1 by 12, this is asymptotically normal 0, 1, and this happened when mn both greater than 8. Note that it is considered the best non-parametric test. This is for location. This is a best non-parametric test for location, since asymptotic relative efficiency of U test is very high. Because its asymptotic relative efficiency is very high, so it is best non-parametric test for two sample location problem. And this is another homework. You also check that the W, that is Wilcoxian rank sum test statistics, this is equal to U plus n into n plus 1 by 2. So we conclude that Mann-Whitney U test and Wilcoxian rank sum test, these are equivalent. So I want to stop today. I will discuss this Mann-Whitney U test and Wilcoxian rank sum test with an practical example in my next class. Till then, stay with us. Thank you.